On number 3, we have f of x equals 2 raised to the x minus 1 plus 6. Of course, me, I always draw my original. So my original exponential function looks like this. My asymptote is at y equals 0. In this problem, this original has been shifted to the right 1 because this is happening up inside the function. So it's a horizontal shift. It does the opposite of what you think it does. So it's going to shift to the right 1, and this plus 6 is going to happen vertically. So I shift to the right 1. So I'm going to shift right 1 and up 6. So I'm going to shift right 1 and up 6. I'm going to take this one and my new graph. I'm going to go up here and I'm going to draw my new asymptote at y equals 6. Now, normally, remember right here, my y-intercept is 1 above that asymptote. So I'm going to go 1 above, and then this right here says that I should shift right 1. So I'm going to shift over right 1, and then I'm still going to swoop. It still has that same look. Now this y-intercept is something different now. I've just taken the one I knew and shifted it right 1. So everything has shifted up 6 and to the right 1. So now my domain, remember your domain of any exponential function is all real numbers. The range is lowest y value to highest y value, so 6 included, not included, 6 is not included, so that's a parenthesis, up to infinity. The asymptote of an exponential is always y equals something, y equals 6. Right here, I shifted that original asymptote up 6, everything shifted up 6, so y equals 6. The end behavior, as x approaches as far left as it can approach, as x approaches negative infinity, f of x is going down, 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 but not to negative infinity, but to that asymptote. So f of x approaches 6. And go the other way, as x approaches positive infinity, what's y doing? It's going up to positive infinity. So as x approaches positive infinity, f of x approaches positive infinity. And the graph from left to right increases. So this graph increases. Number 4, we have f of x equals log base 6 of x plus 1 plus 3. Now, here I have parentheses. I'm going to pull this back down for just a minute. Look at this exponential function. This has stuff happening up in the exponent. That happens horizontally. That's affecting my x's. So that's going to be a horizontal shift. This is not inside. This is outside the function. It's outside that raised to the power. So this is happening to the y's. So this does vertically. Now in a logarithmic function, the only way that you can tell if you have a horizontal is something happening inside parentheses. There's no raising up into an exponent. So keep in mind that when you have parentheses, that means that you have a horizontal shift. There is no reflection in this when there is no negative in front of the entire function, and there is not a negative sign in front of x, so there's no reflection. There's a shift horizontally, 1 left, because inside does the opposite of what you think it does, and then up 3. So I have a shift of left 1 and up 3. So the original logarithmic function, I know my asymptote is at x equals 0. My x-intercept is over 1 up 0, so there's the original. So everything, asymptote, graph, everything is shifting left 1 and up 3. So I'm going to come over here and I'm going to shift left 1. So my new asymptote is now at x equals negative 1. This x-intercept is going to shift left 1. So I'm shifting from here, left 1 and up 1, 2, 3. And I know I'm swooping right up against my asymptote and swooping out. So there's that function. So here's what I'm looking at to graph, or here's what I'm looking at to find my domain and range. My domain is as far left as I can go, which is negative 1 not included. So the domain is negative 1 to positive infinity. the range is always all real numbers. You can put all real numbers, that symbol, or you can do negative infinity to positive infinity. The asymptote of a logarithmic function is always x equals something, and it's going to be whatever your horizontal shift was from 0. So I shifted left 1, so x equals -1 is my asymptote. My end behavior, go as far left as your x values go. So as x is approaching that asymptote, it never goes past that asymptote. What's y doing? So x is approaching -1, and y is going down. So as x approaches -1, f of x approaches negative infinity. As x is approaching, now go the other way, as x is approaching positive infinity, f of x is also approaching positive infinity. So as x approaches positive infinity, f of x also approaches positive infinity. And the graph increases. So there's number 3 and 4. 5 and 6, of course, will be on another video.